Hello, everyone. I am glad to be here at USAR. My name is Natalia da Silva. I am assistant professor at Universidad de la República in Uruguay. And today I will present transforming data into information, overcoming challenge in educational data analysis. In this project, we are working with learning management system data or learning platform like Moodle and Blackboard. And these tools are become really important tools in education because they generate a huge volume of students and teacher data in a daily basis. And it's really important how we can transform this data into relevant information for decision making. And there are a lot of challenges involved because the data structure and the complexity of the problem is sometimes really important. And it's very difficult sometimes how to summarize the learning process based on this information, this data, okay? And it's more common, okay, that you can find learning management system data from grad students at different universities, but it's not as common to find that kind of data in primary school level for a complete country. That is the kind of problem we are working here. We have data from learning management systems at primary school level for a complete country, okay? And that incorporates a lot of complexity in the problem because there are a lot of variation involved that we need to analyze. And then the program we are working is based on one laptop per child program. This program aims to improve the learning in the poorest region of the world by providing laptops to children for use at school and home. Uruguay implemented this initiative in 2007, and the name of this initiative in Uruguay is Plan Ceibal. And now every child in public education system has a laptop or tablet with specific content to learn. And now this was extended to secondary school and was really important during the pandemic because childs have the connection with the school and the classes were online and was really play a key role during the pandemic. Well, this presentation and this project was founded by a national grant by the National Agency of Research and Innovation in Uruguay in collaboration with Fundación Ceibal. My team at the university is composed by Ignacio Álvarez, Mauro Loprete, Oscar Montañez, Jimena Padini, Bruno Tancredi. And this project has three main line of works. We first want to develop some tools to evaluate and monitor the use of the learning management system in primary school in Uruguay. And we implement a monitor based on a Shiny app. The second objective or the second goal is to identify the key drivers in the use of the learning management system and try to understand all the sorts of variability and define some measure of student engagement. And finally, we want to predict student performance in English tests based on their use of the learning management system. We want to connect the use in the platform with the performance in some specific test. In this case, we select English test, okay? And in this presentation, I just will focus on in some part of the first and the third line of work, okay? Based on the learning management system monitor, what kind of data do we have? We have students and teacher use of learning management system. We are having information from some platform with a general purpose. We have information from 2018 to 2021 for 4, 5, and 6th grade. They are students with between 9 and 11 years old. And if you can observe here, yes, pre and post pandemic, the number of observations that we have changed a lot. Okay, we have data. We have data for every day. What students are doing in the platform, they are uploading a file, they are making a comment. Okay, but before pandemic, we have around 2 million data points, but after pandemic, that number increased a lot. Okay, we have around 8 million the observations there. And a key relevant point is how to work with this kind of data, how to transform this data into relevant information for decision making, and how are relevant summaries, yes, for this kind of data, how to summarize information and how process the data with computational efficient tools. And when we were thinking about the monitor, and we think, okay, we will use a Shiny app, we think this Shiny app should be scalable, should be modularized, should be flexible enough to maintain, modify, and test the application, should be reproducible, and we would like also to be prepared to be used for many users at the same time. Then at the end, we decide to develop this platform with Rhino, okay, and connect the platform with a Postgres SQL database to make the Shiny application more efficient, okay? Because we are working with a lot of data and a lot of questions in each level of analysis. And our application, if you are going there, you have different levels of analysis. We have national level, we have school level, we have grade level, and we have class level. And for each of the tabsets that you are seeing there, we can select the year, we can select the different engagement index, different location, okay? And then we have to think a lot how to split the data and the problem to make this Shiny application in a production way. Okay, right now we can focus on the predictive models, okay? In the predictive models, we want to see and predict the English test performance based on learning management system student usage. And we have here different problems. We would like to predict the final points in the English test for each student, or also we want to predict the average point in the English test at the class level. And finally, we want to predict whether a sixth grade student will reach the A2.1 level as is expected, okay? But at the end here, I will focus just in the third model, the third problem. But for all the different problems that we try to have an answer, was really important the workflow that we will use, and we use tidymodel for that, for test all the different kind of models and compare the models, okay? And that was a key point in this part of the project. In terms of academic performance, we have different sources of information. First, we have the performance data. We have the result from a adaptive English test. Each student have a test at the end of the year. Our academic years go from March to December, and then there are some students that are randomly selected to take the test in November and December, and we use information from a learning management system that is specific for learning English, and we use that Little Bridge platform. The students have different activities, different homework games to learn English as a second language. And then in this part, I will focus in sixth grade student. They are 11 years old, and our response variable will be if this student reached the expected English proficiency level or not. Then that is a classification problem, which level reach the expected level or not. And we have here some exploratory data analysis. Here we have a Sina plot where we have the English test point that are from 200 until around 800. And what we can see is the different grades, 4, 5, and 6. And the color are the categorized levels of the English test. In 4 and fifth grade, we can see a similar distribution. We have more observation here that is expected, and also we have more observations in sixth grade that is expected. But one thing that we know is in sixth grade, they expect that the student reach at least to A2 level, that is from here to here, but you can see that there are a lot of students that are behind. Then we need some kind of tool that work as a early tool that say, okay, these students are not doing well, probably will not reach to the level that we want, and do some intervention there. And if we are observing or try to see the relationship between socioeconomic context to the Little Bridge work, okay, the relationship between the socioeconomic context with the work in the platform, here we have the total number of attempts, because they have a lot of different activities and they can try more than once, and we are collecting that information monthly, accumulated, and in each month, and each panel represent the grade and the color represent the socioeconomic context, and we can see a similar pattern here. But also we can see that the socioeconomic context, the higher level, that is blue, yes, they are working more across all the different grades. Okay, if you are in a higher socioeconomic context, you can see that they are having more total attempts than in another socioeconomic context. And what happens if we want to see some relationship between the platform work or platform usage with the academic performance? Here we have, in each panel, we have the socioeconomic context from 1 to 5, being 5 the most, the higher socioeconomic context, and the color represent the different levels in the adaptive English test. We can see across all the contexts, the pattern is similar. That means that if you are here, we have the correct answers, and we can see that if you are working more, if you are having more work correctly done, your performance in the adaptive English test will be better. This is not causation, but we can see in that relationship. And that relationship keeps across all the socioeconomic contexts. If you have more correct answer, you will have a better, or look like you will have a better performance. Okay, there is an association between that. And well, our classification problem there is focused in children in sixth grade, and we want to check if the response will be 1 if they reach A2 level or higher, and 0 otherwise. And we are using information from March to July. Why? Because we want to use the predictive model as an early alert. Okay, if we can find some students that are with problems or probably will not reach to the expected level, we want to do some kind of intervention. That is why we are using until July, because the academic year ends on December. And also we fit different statistical learning methods, a lot of different statistical learning methods. And in general, in most cases, the best models get an accuracy around 70, and that is good enough for the complex problem that we have. And at the end, we select the Bayesian additive regression tree as the final model, because in this problem, we think that school effect is important. Then we want to include a random effect at BARTs, allow us to do that. And other statistical learning method, we cannot have that. And also BART allow us to have an internal uncertainty measure for our estimation. And what is a Bayesian, in general terms, Bayesian additive regression tree? We have a tree like a recursive partition of the predictor space, okay, like a card. But what is the difference? Since we are in a Bayesian framework, you have to put priors everywhere. You have to put prior for the tree structure. You have to define prior for the final nodes, you have to define prior for the cut point, and so on. And then if you have, you can specify the Bayesian additive regression tree as the sum of the different single trees. And also in this model can be extend the regression tree as classification regression tree. And also you can incorporate a random effect like we can see here, okay? And at the end, we feed a BART, okay? We feed a BART. And there are, we can see here that we have the point estimation of the random effects for each of the classes that we have, because we include a random effect for each school, not class, school. And we have an uncertainty measure there. Okay, and what we can see, there are schools with positive effect in most of the socioeconomical quantiles here. That means that we want to know what schools are this one, because they are doing better than average in terms of performance in the English test, and we want to learn from there. But also we want to see what happened here. These are schools that are doing worse than average, okay, and we need to go and make an intervention. And this information is really important in terms of the application problem, because we have information even in the socioeconomic context that are really good. We have schools that are doing very bad, and we want to see why they are doing that. And also we have a school even in the lower socioeconomical income that are doing better than average, and we want to learn from them. And at the end, also we use the predictive model with BART with some synthetic students. We have students, we simulate students with a bigger usage in the platform. Medium usage is green, and slow and lower usage is red. And here we have the probability to reach to the expected level in 6th grade, that is A2. And here we have the socioeconomic context. What we can see here is like, it's more likely to reach to the expected level if you are working hard, but also it's more likely for all the different levels, okay? But if you are working hard, look like it's more important working hard than the socioeconomic context to reach the level that you want, because I am comparing this one in the worst socioeconomic context, and the probability here is bigger than the probability in the higher context, okay, where if they are not working so hard, they are not reaching to this level, okay? Then it's important, and it's important information that we get from the model to get some conclusion about the relationship between usage and see what makes you reach to the level that we expect in 6th grade. As final comments, we can say that learning management data can be used to improve education, okay? We can generate information to make informed decisions. Transforming data into relevant information requires appropriate computational tools and also statistical methods. Then when we are working with big data or data that are huge and complex, we have to select the specific tools that make this project work correctly. We present some summary statistical information in a Shiny app based on Rhino to monitor and evaluate the learning management usage at different levels. And we have some information to analyze the data in an efficient way. We also feed BART model based on additive regression tree to predict the academic performance at the end of the year, just using information until July, because we want to use that information as an early warning tool, okay? Then we use the result, yes, as an early warning tool to identify if students are at risk. And also we use the model to identify centers in need of intervention, as well as centers to learn from. Some of the relevant tools used in this project for data wrangling, visualization, and predictive model were data.table, Shiny, Rhino, Plotly, ggplot2, tidymodels, and dbart, and also databases with Postgres SQL. Thank you for your attention and see you around.